sine function graphs, and the general equation for a sine function is sine function graph is y equals to a sine n x plus or minus h over n plus or minus k, and h over n is the phase shift translation from the x-axis, and could be plus or minus, negative or positive, negative direction, and plus or minus k is a translation, k units up or down from the y-axis. And the n is a dilation factor, so we put it as a reciprocal. We put it 1 over whatever n value is, dilation factor from the y-axis, and a is the amplitude. So if this is my original function, which is the original sine graph, so the dilation factor in this case is 1, which is the amplitude, and the n value is also 1, so my period is only 2 pi. So we divide the period into 4 equal sections. So if I actually halve these halves of, well, then it's based on the unit circle, so the endpoints needs to be marked. So it's better to use dots first before you actually get the whole graph. So sine of 0 is 0, sine of half pi is 1, sine of pi is 0, sine of 3 pi is -1, which is up here, and sine of 2 pi is 0 based on the unit circle. So the next step is just to join the dots. And that's the original graph. So if I have a reflection on the x-axis, that's going to be a reflection of this whole graph. So let's have a reflection on this graph. So that's going to be this. If that was to be reflected, and that's how it looks. This is how it will look like if it's reflected on the x-axis. So that means y in this case will be negative sine x. Let's have a look at a scenario where we have other transformations whereby we have an translation, and let's see what happens to the mean position. In this case now, the mean position is actually 0, so where it's starting from. So let's see another example that has been translated. So this example here. So a few things to be mindful of. The mean position. Now that our mean position is 3, where we're starting it from. Our amplitude is 2. So the maximum value, or the maximum point of the graph will be 5. Will be 1. So because this has been shifted 3 units up, So it's not on the x-axis. So that means we're not going to have an x and x-intercepts. No x-intercepts. All right, now, so the next thing is we need to find out the y-intercept. And also we need to find out the value of x at the maximum and also the value of x at the minimum, and also the endpoints. Based on those, we can easily graph. So let's start with the y-intercept. Based on unit circle, so that's going to be square root 3 over 2, negative square root 3, so that's the negative out, square root 3 over 2, so which gives us 3 there, negative square root 3 plus 3 there. So that's my one of the endpoints, as that was has restricted. And also it's the x-intercept. So we can also find the other endpoint, which is 2 pi, by substituting back into the original function. Again, that's 4 pi, so that's sort of going through the unit circle twice, and minus pi on 3. So that still gives us the same answer, which is that. So those are my endpoints. Our endpoints were we need that information, and my other endpoint was the same y value. All right, the next thing is to find out the values of x at the maximum and at the minimum as well. X values at the maximum and the minimum, at the minimum and the maximum. So we had this, and our maximum value was, our minimum was 1, our maximum was 5, and our restricted domain was 2 pi. All right, so now we have, so that means we're expecting 4 solutions. So that's -1. So that gives us 2 pi, 2x pi sine inverse -1. So that gives us 3 pi over 2. and add 2 pi to this, so that's going to be 3 pi over 2 plus 2 pi, 7 pi on 2. So we need to add pi over 3 on the other side. And if I divide the 2, so that's going to be 6, 9, 11. So that's 11 pi on 6 divided to 2. So that means my x value has to be 11 pi over 12. So that's 23 over 12. I've divided the 2 on the other side as well. So that is the minimum. So when it's minimum, so that's when those are the x values. So that means I also have to get the value of x when it's at the maximum, and the maximum value was 5. So that means which gives us a half and 2 pi to it. So we add 2 pi to half pi, and my next step is to add -3 pi, negative pi on 3 on the other side. So if I take this side, this corner, so that gives us 2x plus and half pi plus pi over 3, 5 pi over 2 plus pi over 3. That's going to be 612 if I divide. So that's going to give me 5 pi over 12. I divide the 2 on the other side as well too. And that's going to be 15, 17 over 12. So 17 over 12 is the maximum. So these are the x values at the maximum, and these are the x values at the minimum. So the x values at the minimum were there, minimum, and these are the maximum side. So we need to graph now. Now we have got our endpoints, our minimum, our maximum, and yeah, because we don't have an x-intercept, so we don't have to worry about that. So now the mean position has been shifted, so that's one thing we need to be mindful of. So let's actually get that one done. So we get the mean position and we get our maximum minimum values. All right, now we have our mean position. We have our graph and our axis. So the next thing is just to label the axis now. So we have the mean position was 3 and the minimum was 1 and the maximum was 5. We have labeled all our values, our maximum, our y-axis. So the next thing is to label the x-axis, or the values. So the value at the endpoints. So let's actually label the maximum. So we had 2 on the minimum, 2 on the maximum, and what were they? So let's actually get our 2 maximum, 2 minimum. (11π/12). Our maximum was 5π/12. So we put a dot there. And we also had when x was 0, the y value was negative square root. So this one here, actually this is my mean position. This is the minimum point, so that's going to be x was 0, negative square root 3 plus 3. So that's the y-intercept. So this is the maximum point, one of the maximum points. So the other maximum point was 17π/12. It's also another maximum point. What that was? So that was 11. No, then we had 11π. We missed 12 actually. 11π was the next number. So if we put the numbers in order, so that's going to be 11π/12. So the next number must be 17π. 17π/12, and the last number was 23π/12 and 2π. All right, now so this is where we start. So this is the mean position, and this is my y-intercept. That is the highest point. So now it comes back to the lowest point, which is this point here. Then goes up the graph. That's the next point. Then back to the mean position. So this one here. So the next minimum point is here. And at this point here, the y values were the same. The endpoints, the y values were the same. So we had 2π and negative square root 3 plus 3. And all we have to do now is just join the dots. So we have to label the values. This is one of the maximum points, and that was my minimum position, one of the minimum positions. And those are the coordinates and the minimum and the maximum. And that's it for this graph.